In this video, we're going to handle another Bode Plot graph for a given transfer function. This time we are going to have a factor that's just a j omega rather than a 1 plus j omega term. So that's going to change things up a little bit. However, we still want to put it in our standard format, which is really only one thing we need to do. Instead of 0.02 j omega, it's going to be j omega over 50. So we're going to go ahead and deal with each thing at a time. So for the part where we have k is 100 here, we're going to have 20 log of 100 is 40. So the graph for this one is just going to be a constant at a value 40 here. Then we can look at the term 1 plus j omega over 50. This one has a break frequency of 50. As all 1 plus j omega terms do, it starts out flat at 0. And then since it's the numerator, once we get to the 50, it's going to go up at a slope of positive 20 decibels per decade. The last one, though, is we have this j omega squared in the denominator. And if we recall, when you have the term that's not the 1 plus j omega, but just j omega, instead of being flat and then a line of 20 degrees slope, 20 decibel slope, this one's going to be the constant slope the whole way through. Now, the default j omega has a slope of 20. J omega squared would have a slope of 40, but this is on the denominator, so it's going to have a slope of negative 40. And we know that at 1 is where it's going to pass the x-axis. It's going to have its x-intercept there. So putting these things together here, we want to draw our overall Bode plot. We know that we're going to need to have 1 here for the j omega squared term. If I go up by a decade to 10, and then another decade up to 100, I can go ahead and mark 50 in there, a little bit past the middle. So at this point in time, we are going to have, we know that it's a negative slope starting out, because the other two are flat. And we know normally it would go through the x-intercept at 1. However, this one here is going to shift it up 40, so at 1, instead of being at 0, it's going to be at 40, going down here. And the slope is at negative 40 decibels per decade. So what that means is by the time we reach one more decade, at 10, is where you're going to get to 0. Then it's going to continue on here. Then when we reach to 50, it was a slope of negative 40, and now at 50 it's going to add positive 20 to the slope from this part over here. So now its slope's only going to be negative 20, so it's going to flatten a little bit but not completely. And this is what we would have. Now, I didn't draw it that well. It looks like the slope changes at 10, so maybe I'll go ahead and try to redraw this a little bit here, just to do the best that I can. So it's going to start out with a slope of negative 40 and then become a slope of only negative 20 when we reach the point at 50. And so this is what the Bode plot would look like for this particular transfer function.